Simple timer start, 40 minutes. Okay, we've got that down here. All right, cool. So we're gonna get started. Okay, so given an array of n integers, construct a product array of the same size such that the ith element of the product array is equal to the product of all the elements from the input array except for the ith element. Okay. So given an array of n integers, so array of ints of length n, and our output is supposed to be a product array, so I would guess a new array, object of integers, integer products, and of length n, so they're supposed to be of the same size, such that the ith element of the product array is equal to the product of all the elements from the input array, except for the ith element. Okay, so I'm just going to try to validate some stuff here. First thing, thinking, so we've got like maybe some empty array. That seems like it would just be maybe like an error or something, or 0 for that input. Let's say we had something like 1, 2, 3, 4. Actually, let's start with just 1, 2, 3, 4. So for that input array, we would expect it to look something like, so 2 times 3 times 4, so 6 times 4, 24. Okay, so it'd be 24 for the first element, because it's 2 times 3, 6 times 4, 24. For the next one, it'd be 3 times 4 times 1, so just 12. For the third element in the product array, it's going to be 2 times 4, so 8. And like it's 2 times 4 times 1, but same difference. And then for the fourth, or the fourth element at index 3, it's just going to be 6. That seems like that's what the problem is asking for. I can't make the assumption that it's always going to be positive integers, because it's just some array of n integers, so they don't give us an indication of the type of like if it is signed or not. So I'm just going to have to handle those sort of test cases. So maybe we can just take this and do -1 or something, and then every so these would all be that. So that would be the same for the first one, 24, but then every one after would just be the negative of that number. So it would be -1 times 3 times 4. So 12, -12, -8, and -6. Okay, cool. We should probably get one where there are multiple negatives. So get something like this, maybe one a little bit longer. 5, so -1. For that test case, it would be 24 times 5, which I think is, what is that? I'll just make sure, 24 times 5, 120. Okay, so this case would be 120. Okay, and then 5 times 4 times 3, 5 times 4, 20 times 3, 60, so -60. Okay, and then for the third element, -2 times 20, -2 times 20, so that would just be -40. And then for the last element, it's going to be negative something, so it'd be 2 times 3 times 4, so 2 times 3, 6 times 4, 24, so -24. Wait, I think I'm getting off base here. So this one is negative, or this is 120. All the rest should be negative, or I'm sure it should be Yeah, they should be negative because there's a negative 1. So 3 times 4, 12 times 5. 12 times 5, or yeah, so this is 20 times 3, negative 60, so that is correct. And then for the third element, it's going to be negative 2 times 20, so negative 40. And then for this, it is negative 6 times 5, so negative 30. Negative 6 times 5, yeah, negative 30. For the fourth element, and then the fifth element, be 4 times 3, 12 times negative 2, so negative 24. Okay, sorry, I kind of, yeah, that it's kind of silly mathematical errors there, but okay, so let's think about this maybe. We've got negatives. I guess does 0 count here? I mean, it's certainly an integer, so that obviously makes sense. So maybe we'll just grab this test case and do like 0, right? So 2 times 3 times 4, same, would be 24, but then all the rest would be 0. Okay, because anything times 0 is 0. And then we could just maybe like a negative 0 or something. And I guess I got to check that. So negative 0 times 4 or something. So it's going to be negative 0. So all of these would be negative 0 then. Okay. And they're always integers. And okay, that sort of checks out for me. We've dealt with the case where I guess we should have a 2-element array, I think. That also makes sense. So like 1 and negative 1. So then for this test case, it would just be negative 1 and 1, right? So if there isn't anything to multiply by, yeah, okay. That makes sense. Let me think if we just have like a, say it's like 1, and we need to like reduce a times c, and then maybe that can just be 1. Actually, does it need an initial value? It does not need the initial value. Okay, so that's going to work for this test case here. Okay, so we've got a couple test cases that we built out and validated some of our assumptions. Let's think about some of the explicit and implicit rules here. So I guess you could say that input is always an array of integers, and they can be positive or negative. Positive or negative integers, including 0 and negative 0. Okay. And the ith element in the product array, so the array that we're returning out of our function, is the product of all elements contained in the input array, not inclusive of the ith element in the input array. So that's what we were seeing up here with all these examples. The value, the ith element, so in this case, the 0th element in the product array is the product of all of these elements. So 2 times 3, 6 times 4, 12. Did I just totally get that? So 6 times 4, okay, 24. all right. Cool. Okay, so that is working. So that is what that explicit rule means. And I think this is kind of an implicit rule here with 0 and negative 0, and having that reflected in the test cases here. These two, 12 and 13. Just given that is a possibility, and they don't say anything about signed or unsigned numbers, so something to take into account. The product of all elements in the input array except for the ith element. Okay, and I guess when we say except, I guess that's just very much like inclusive, or I'm sorry, excluding that ith element. So we're not like subtracting it or anything. It's just it doesn't factor into the ith element in the product array's value. Okay, I think that's pretty clear. I'm trying to think if there's any other major problems that we would run into if we don't have some more explicit rules here. So given an array of n integers, construct a product array of the same size such that the ith element of the product array is equal to the product of all the elements from the input array except for the ith element. So what I'm thinking here, so initially we have some sort of like maybe input validation, which essentially is just ensuring, because the problem says we can expect an array. So this actually might not even be necessary to check if the input is valid, because they say that it should be an array of integers. So actually, this is really, there aren't too many aspects to this problem. So let's think about this. Basically, my general, I think, strategy here is that I just want to essentially like traverse the input array of integers, and basically for each of those, at each iteration, we want to look left and look right, gather all of those elements in the input array, find the product of multiplying all of those elements together with one another, and then pushing that into the result array. So that's like my general, that's basically the problem here. And so I would just need to establish formally what that looks like. So we just need to traverse the input array of integers and gather all of the elements to the left and right of the current index, current element at I, or at current index. We need to gather them all, and then once we've gathered them, before we go to the next iteration, we need to find product of gathered elements and push that product, or I guess calculate product of gathered elements and push that product into result array. Okay, so those are calculate. Those are our two subproblems from what I understand. And so I'm going to try to write out some more formal pseudocode here. So first thing is we want to traverse input array of elements with a normal for loop. And for each, at each iteration, we need to slice from 0. So for the left side, so for left of current element, slice from 0 up to the current index. That is what is expressed up here with I, current index. And then for right of current element, we want to slice from current element plus 1, because it's not including the current element, up to the end of the array, end of the array. So that would just be input array's length minus 1, which we're using in our control of this for loop, that value. Okay, and I don't think I need to do this every time. I think I can just basically, we don't have to optimize it. That doesn't matter. We can just focus on getting a working algorithm first, and then if there's time, we can optimize it for performance. Okay, so we need to do these, and then once we have both of those arrays, maybe we would concat these two array objects and find product once we have this product, push product into result array. And we forgot to declare, so declare product result array, product array as an empty array. Okay, so we're going to run through this with some of these examples. Just going to paste these down here. So I suppose for this situation, I'm going to make the assumption that we just want to return an empty array here. So guard for empty array scenario, or empty array. So that test case will have been handled. And so then for this one, there's a 2-element array for our input. We would declare the product array and then traverse. So here we would be at index 0. So I is 0 here. I'll just write that out. I is 0. And we've got our result array. Actually, product array right here. So product array looks like this. It's an empty array. And yeah, let's just grab this. Input array looks like this. Okay. So let's see. We've got. I'm just gonna let my dog in real quick. Sorry about that. Hi, buddy. Hi. You need to go lie down. Go on. Okay, so the current element is 1, and I is that. So if we're slicing, so like let's just go to here. Say we've got this array. We slice from 0 up to the current index 0. So there's nothing to the left, which makes sense. We have this, and we slice from the current index 0 up to the end, and so it would just be length 2, would be that, right? So but we don't want to include the current index, the element of the current index. So it would just be that. That is the total. So that's the only value that's going to be in our array that needs to be reduced. So it would just be -1, and so -1 is pushed into our product array, so -1, and then the same is true for the opposite case. So when I is 0, we are then going to be at this element. So I'm sorry, when I is 1, we're going to be there. And if we can just modify this a bit, it's going to be first slicing to the left. It's going to be the current index, 0 up to the current index, which is 1. So that's just 1. And if we slice to the right, we're going to see, so say we have this slice from the current index plus 1 up to the end of the array. So current index is 1 plus 1 up to the end, which we know is 2. It's just an empty array. So if we concatenate empty array with that array that contains 1, we just get that, right? And then what that would look like, once we have this, we want to reduce it. So accumulator current, and then accumulator times current. And I think I left off, yeah. Missing, yep, I just forgot the, what makes it a callback function? Okay, so got that. And I think, let's 1, 2, reduce, oh, there's just, yeah, okay, great. So that seems to be working for that test case. We should probably run through another one. We have plenty of time, so we can reset these values, and yeah, okay. So let's take this example with a -1. So I is 0. We've got this empty result array. So if we're walking through our algorithm, we are traversing it with a normal for loop. And for the left side, it's just going to be nothing, right? As we initially saw, if the index is 0. And then for the right side, it's just the slice from the current index plus 1 up to the end of the array. So let's say current index is 0, so we take our array, slice from 0 plus 1, so 0 being the current index, and so we're not including that value, and we're going up to the end, and I'm just going to just count here. It's of length 4, and that returns those elements. And so I think I need to, it's actually just the input array's length. It's not -1. Yeah, and that looks right. And let's say we had moved all the way to the end, so jump ahead to index 3. So it would just be 0, so it would be the array slicing from the current index, so 3 plus 1, or rather, I'm sorry, 0. So this is for the left side, 0, and it would be up to the current index, so 3, and it would be those elements not inclusive of that 4, which is what we're looking for. So yeah, I think I validated this these steps substantial or to an adequate degree. So I'm going to start writing my algorithm here. And what are we going to call this? Just like, I'm just going to call it make product array. Okay. Array. And you do that. Okay, cool. So I'm going to leave those there and get started. Return empty array. Something's just occurring to me now. If it is a sparse array, then how do we want to deal with that? So let's say we have another test case here, and we're just going to call this sparse, and maybe can declare that up here. So const sparse array. Sparse is an empty array, and then we're going to modify its length. Oops, length is equal to like 10 or something. How should our algorithm deal with that? Because we'll just say return input for now. So if we are just looking at that one test case, get out of here. So node 1, okay, 10 empty items. How do we want to deal with sparse arrays? Okay, so if it's greater than, so I guess we could just access some value. So if the length is not equal to 0, which we saw here, its length was 10. Comment this out. So its length is 10, so it's not going to be called by this guard clause. So we need another one where we can check if input at maybe the 0th index is undefined, or is the type of the let's do type of the value at that index is equal to undefined, or rather, if it is not equal to a string, then we can just return just an error message or something, sparse or invalid input. All right. Okay, so now that should be handled. Great, and we're seeing that. So we need to just comment that stuff out. We don't really need to be concerned with that anymore. Okay, and so if we look at our algorithm here, we've guarded for empty array and sparse array with these two guard clauses. So now we can get into the core algorithm. And I said I wanted to use just a normal for loop, so we'll do that. And input length, and I don't think we're concerned with the accessing the actual element at the current index. So yeah, we just need to translate what we have up here into formal code. So I'm just going to grab all of this and just drop it in here with comment. So you can just comment that out. Okay, cool. So basically we just want left, so I'm just going to declare a variable left elements, and it's just going to be from 0 up to the current index. So take input slice from 0 up to the current index, and let's just log that out for now. Left elements. Okay. And let's just look at this last test case. Invalid input. So if it is not a string, oh, if it is not a number, so now we should be getting through the loop. Okay, so this is for the left side, so there's nothing the first time, which is what we expected. And then we've got -0, and then -0, 2, and then -0, 2, and 3. So that's what we expected. So this part is working just fine. Let right elements be input slice from the current index +1 up to the end. And so I'm just going to actually grab this and just place it here. We'll just say, we'll just call this lang. Okay, we'll just use that here up to lang, and we'll do the same thing here just to verify that that is what we expect it to be. Right elements, okay. So now it's going to be not including the -0 the first time, which is what we were expecting, and then not including the 2 or the 0. So just 3, 4, and then 4, and then nothing. Great. So our loop is working as it is intended. So we don't need to do any more logging, I believe. We can just simply implement the rest of the algorithm. So let's take a look at this. Just need to concatenate the two arrays. So we can maybe just take, we'll do another variable declaration. So product. Okay. And let product to left elements concat with right elements. And then we want to reduce that to be accumulator current, and that would just be accumulator times current. Okay. Is there anything else there? All right, that looks good. And then we should just push product into products. Okay, and then we should just return out that products array. And we're seeing what we expected here, so let's, I'll just pull up all the test cases and we can walk through them just to ensure that our solution is working. So empty array, which is, invalid input. So we're catching the sparse. So this looks good here. This one looks good. -1, 1. 24, 12, 8, 6. Cool. 24, -12, -8, -6. 120, -60, -40, and so on. Yeah, okay. So this, I think, is a fine solution. It's not perfect. And I think there's definitely an optimization here where you don't do this every time. But